All right, let's talk about solving quadratic inequalities in one variable, meaning it's not a function, there's no y and x, they're just x's. So the steps to do this are to get everything on the same side, and then we're going to find the zeros of the corresponding equation, we'll talk about that in a second, and then make a number line and test intervals, and again we'll talk about that, and then write your answer. So I'm going to start with a problem that's already like in fully factored form, and this is one of your Alex topics. So let's say that I want to solve this inequality for x. Now, the first thing is to get everything on the same side. That's already happened here. The second is to find the zeros of the corresponding equation. So what I want to do here is to find the zeros of x minus 7 times x plus 1 equals 0. And the reason we find the zeros is if this inequality, once everything's on the same side, says that this stuff is either less than or greater than, depending on the particular problem, 0, meaning we want to know whether it's positive or negative. And where the quadratics can switch from positive to negative are places where it equals 0. So if we find where it equals 0, then we can sort of figure out where it's positive and negative by doing some testing. So the zeros of x minus 7 and x times x plus 1 equals 0 are 7 and negative 1. And you know that because of the zero product property. So that's the second step. The third step is to make a number line. Now, the number line, when you were in Algebra 1, your teacher probably made you put like tick marks for 0 and made them all like equally spaced and yada, yada, yada. Here, I'm not interested in that. I'm literally interested in having a number line that has two numbers on it. The zeros that I found, negative 1 and 7. Those are the places where it equals 0. So now in order to figure out where it's less than 0, those two numbers that I placed on the line broke that line up into three parts. And what we're going to do is basically pick a test number for each of the parts. It's just like kind of what you did with the test point when you're graphing the quadratic inequality functions, but this time it's just a test number because we're only dealing with a number line. So I'm going to test a number that's less than negative 1 in the inequality. So when I test, say, negative 2, that would give me negative 2 minus 7 times negative 2 plus 1. And I'm questioning, is that less than 0? So is this true or not? So if I look at this, I'm not even going to bother to actually do the math. Negative 2 minus 7 is going to be a negative number. Negative 2 plus 1 is also going to be a negative number. And when you multiply a negative times a negative, that'll give you a positive. A positive number is not less than 0. So the numbers in here are going to give you positive numbers, not negative, so it won't be less than 0, which is what the original problem wanted. So I'm going to follow the same process without writing all of that out. So if I pick a number between negative 1 and 7, that's, say, 0. If I plug it into the original inequality, 0 minus 7 is negative, 0 plus 1 is positive, a negative times a positive is a negative, and that is less than 0. So that error works. I want to test a number bigger than 7, say 8. 8 minus 7 is positive, 8 plus 1, positive, positive times a positive, positive, which is not less than 0, so that doesn't work. So if I were shading regions of the line by checking, the parts that I X'd over wouldn't be shaded, but the part that I have a check over would be, right? And then, remember, if it's not an equal to sign on the inequality, these would be open circles on the numbers themselves, because we're not including where it actually does equal 0. So now I'm ready to write my answer. My answer here would be negative 1 is less than x is less than 7. So let's do another example. Let's say 2x squared minus x is less than or equal to, let's make it greater than or equal to this time because we did less than last time, 6. So we need to get everything to the same side, so we're going to subtract 6 from both sides. We need to find the zeros of this equaling 0, and I'm going to do that by factoring because I can tell this factors. So let's see, if I went through the process of factoring, I get two numbers that multiply to give me negative 12 and add to give me negative 1. Those two numbers are negative 4 and 3. I'm going to use the box method. So 2x squared minus 4x plus 3x minus 6. Common factor in the first row is 2x. This is 2x, this is 2x squared. This has to be an x. X, this is 3x, this has to be a 3. 3, negative 6, so this has to be a 2, and that matches up. So it's 2x plus 3, and x minus 2 is greater than or equal to 0. So the zeros of that would be negative 3/2 and positive 2. So I'm going to draw my number line. Negative 3/2, positive 2. It's included this time, so I'm going to put a closed circle on there. And then I'm going to test numbers. So a number less than negative 3/2 would be, say, negative 2. That would make this negative, and this also negative, which is positive. So that one would work. It would be shaded because I want things this time that are greater than 0, because that's what positive numbers are. And then a number between negative 3 and 2, say 0. This would be positive. This would be negative. So that's a negative number, which is not greater than 0, so that doesn't work. And then a number bigger than 2, so say 3. That would make this positive. That would make this positive. So that does work because positive times a positive is greater than or equal to 0. So when I go to write my answer here, I've got two sort of separate sets here. So I'm going to need to write two inequalities. Whoops. X is less than or equal to, now remember it's equal to because it was equal to in the original problem, negative 3/2, or X is greater than or equal to 2. Now, I could show you one more example that basically where the numbers aren't pretty, it doesn't factor, but if it ever doesn't factor and you're trying to do one of these inequalities, all you have to do is when you're finding the 0 of this, use the quadratic formula, and then you'll have some decimals to put on your number line, and then you just go back through and do the sort of same testing process. Hope this helps.